we know all matter is made up of molecules, and each molecule is made up of atom, one or more atom. And if we look into an atom, what do we see? In an atom, the central part is the nucleus, and surrounding the nucleus, electrons are orbiting. This nucleus is positively charged and is concentrated at the center of the atom. So if we look into an atom, this is the picture of an atom. This is the schematic representation of an atom. Here you can see at the center an atom has the nucleus, and surrounding the nucleus electrons are orbiting. So these yellow colored dots are the electrons. These are the K shell electrons, and surrounding second shell is the L shell electrons, and so on. But we will be focusing on to the central part, the nucleus. The nucleus is not as big as you see in this picture. It is very small. If you compare the nucleus with a cricket ball, if nucleus is of the size of a cricket ball, then an atom will be of the size of a cricket stadium. That is the comparison of size between a nucleus and an atom. So inside the nucleus there are two components. They are proton and neutron. So protons and neutrons are the particles that will be constituting the nucleus. The protons are positively charged and neutrons are neutral. So P for P, that is protons are positively charged, and N for N, neutrons are neutral. So what will be the effective charge of a nucleus? So protons are positively charged and neutrons are neutral, means a nucleus will be positively charged. But an atom as a whole is electrically neutral. How does that happen? That happens because the nucleus is positively charged and the electrons are negatively charged. So if we consider an atom as a whole, the central part is positively charged, which is the nucleus, and the surrounding negatively charged part, the electrons will cancel that positively charged part. So if we consider the nucleus alone, the nucleus is positively charged. So this is the nucleus. Nucleus is composed of protons and neutrons. Protons are positively charged and neutrons are neutral. Here you can see the blue colored dots represent proton and the red colored dots represent neutron. A number of protons and neutrons will be constituting one nucleus. So let us learn the nuclear symbol or atomic symbol. Here you can see a model depiction of an atomic symbol. Normally, we will represent an atom as ZXA. So X means the atomic symbol which is abbreviated form, that will be representing the chemical formula. Then this Z will represent the atomic number. Atomic number means number of protons in a nucleus. So if there are 3 number of protons in a nucleus, the bottom number will be 3. Then the chemical formula for a nucleus containing 3 proton is lithium. So the symbol will be Li, and the number written in the upper part is the mass number. Mass number means number of protons and neutrons in atom. You have to note It is not the number of neutrons, it is the sum of number of protons and neutrons that is written in the upper part. So for lithium, suppose there are 3 number of neutrons. Then what should be the number that we want to write in the upper part? It should be 3 number of neutrons plus 3 number of protons, right? This sum should be written here. That is 6 should be the number in the upper part. So this is the representation of a nucleus. Let us look at another example. Here we see a carbon molecule. A carbon molecule in its nucleus has 6 number of protons and 6 number of neutrons. In the outer shell, a carbon nucleus has 6 electrons in the outer surface. We will not be looking at the number of electrons here. We are only concerned about the nucleus. So we will look into the number of protons and neutrons. So a carbon nucleus has 6 protons and 6 neutrons. So what should be the nuclear symbol of a carbon nucleus? It should be C for the chemical formula for carbon, C, and the bottom number should be number of protons, which is 6, and the number written here at the top position is the sum of number of protons and neutrons, that is 6 plus 6. So this is the mass number, which is 12, sum of number of protons and neutrons. So this is the nuclear symbol for carbon. Now let us do a problem. I have a question for you. How many protons and neutrons does the following isotope of nitrogen atom has? So I have written a chemical formula here. An atomic symbol here. It is 7N14. How many number of protons are there in this nucleus? And how many number of neutrons are there? Can you find the answer? I will pause for a moment and you find the answer, and then I will discuss the answer. I hope the question was easy for you. So how many protons are there? This number represents the number of protons. So that means 7 number of protons are there. How many neutrons are there? Protons are 7. Number of neutrons, is it 14? It is not 14. Okay, you have to be careful when you find the number of neutrons. To find the number of neutrons, you need to subtract the mass number, the atomic number from mass number. 14 minus 7, which is 7. So 7 is the total number of neutrons in this nucleus. How does 7 become the answer? We know 7 number of protons are there and number of protons plus neutron is 14. So to find the number of neutrons, we should subtract the number of protons from the total sum, right? So 14 minus 7 should be the number of neutrons. 7 is the final answer. So in today's lesson, we have learned about the structure of an atom, then about the structure of the nucleus. We have learned about the constituent particles, which are protons and neutrons. Then we learned about nuclear symbol. And with this, let us move on to the assignment. Thank you.